Hello my dear viewers, you are most welcome and thanks for watching. If you are new to this channel, please kindly subscribe, share and watch up to the end so that you don't miss out. And we are going to talk about alkalis and bases. But before we jump into today's lesson, let's have a preview of the previous lesson. In lesson 2, we talked about the properties of acids. We also looked at the common acidic substances. So these substances we always interact with, which ones are acidic, we also looked at them. Then we also looked at the importance of acids, or you can say acidic substances, and we talked of them. So in today's lesson we are going to talk about alkalis and bases. So we are going to look at one, the definition of alkalis or bases. So we are going to get to know what a base is or what an alkali is. We shall also talk about common alkaline substances that are readily available. Then we shall also talk about the importance, rather the significance of alkalis and bases. So now we are talking about alkalis and bases. What is an alkali, or what is a base, and how are these two related, or what is the difference between them? We are saying that an alkali is a soluble base, meaning that any base that dissolves in water, then we form that solution of the base, which now we are calling the alkali. That whereas a base is a substance that reacts with an acid to form a salt and water only. So it is a substance that reacts with an acid to form salt and water only. For example, we can have solid sodium hydroxide, or we can call it the sodium hydroxide pellets. We can also have solid potassium hydroxide, solid potassium hydroxide, etc. We are saying that all alkalis release hydroxide ions when dissolved in water. Remember, for the acids, we release the hydrogen ions, whereas for the alkalis, as they ionize in water, they do produce the hydroxide ion. They do produce the hydroxide ion, which are negatively charged. It is the hydroxide ion that makes a substance behave like an alkali in aqueous solution. So we are saying that when this substance dissolves and produce the hydroxide ions, it's now the presence of these oxide ions that determine the alkalinity of this aqueous solution, or of this solution of the soluble base. And we are saying that most vegetables like amaranthus, SSP, dodo, and spinach, that is kumawi, contains alkalis. So now let's talk of the commonly alkaline substances available. First and foremost, we have this, and this is the alvela, chigaji. We are saying that this is alvela. So this one is alkaline in nature. Alright, we can have the second one as okra. Members, okra. In Uganda, it is called bamia. Bamia is alkaline in nature. We can also have the baking powder. Or somebody can call it baking soda, then the chemical name of this is sodium hydrogen carbonate. That is chemical name, though it can also be called sodium bicarbonate. All this one means the same thing as we are seeing it there. Alright, we can have another one, and this is ash, a vu. The real ash, it may be ash of the wood, it may be of maybe banana peelings, maybe of cassava peelings. So we are saying that the ash is also alkaline. It has that element of alkalinity. We can also have the next one, cement. This is cement. Or somebody can call it slaked lime. Slaked lime. So this one is alkaline in nature. Cement, the one we use during construction of houses. Alright, we can have another one. This is the bitter tomato. Or you can call it in Uganda ntula. So these ones are saying that they are also alkaline in nature. The next you can have the eggplant. Biringanya. It is also alkaline. We can also have the next one, and this is amaranthus, or you can call it amaranthus SSP. And this one in Uganda is called dodo. Dodo is alkaline in nature. And by the way, most of the foliage leaves of the plants, they are alkaline. Squeeze between the hands, you'll see that there will be some more slippery. Let's talk of the properties of alkalis or alkaline substances. So, what have we now based on to categorize those materials above as alkaline? Is now the properties. So we base on the properties or characteristics. It is now the characteristics of those substances that we have based on to say that they are alkaline in nature. Alright, number one, we can have that they are bitter and slippery. Next, we say that they turn red litmus paper blue. And this one indicates that they are alkaline. It means that when we get a red litmus paper and we dip it in the solution of one of the substances we have listed above there, the red litmus paper will definitely turn blue. Alright, it's saying that they are soapy in that they form leather when squeezed between hands. This one I've already talked about it. When you get now those plants or the substances that are alkaline, and then you try to squeeze them between your hands, you find that they are forming some kind of foam or leather. So it's that they are soapy and that they form leather when squeezed between hands. Next, you can talk of the reaction, how they react. So we are saying that these alkaline substances or alkalis react with acids to produce salt and water only. So this is a chemical property that these alkaline substances or alkalis exhibit. Alright, we are saying that their alkalinity is as a result of the only negatively charged hydroxide ions released in aqueous solution. As we said earlier, that these alkaline solutions or the alkalis are formed as a result of dissolving the soluble bases, which now produce the hydroxide ions. And we are saying that these hydroxide ions are the ones responsible for the alkalinity of the solution. These hydroxide ions, they are having this, that is the formula of the hydroxide ions, and we are seeing they are negatively charged. Next, we can say that they have pH values which are above 7 or beyond 7. Remember, as we are talking of the pH scale, I know we shall talk about it. When it's at 7, that means that the pH is neutral. Above 7, that is alkaline. Then below 7, it is acidic or acidity. Alright, we can have now the importance of alkalis or bases or alkaline substances. So how important are they? We always use them, sometimes knowingly, sometimes unknowingly. Then how are they helpful to us? What are the significances of these substances that are acidic? I mean that they are alkaline, basic or alkaline in nature. So we can talk of the first one, that alkaline substances like baking powder. I think we have now known what baking powder is. Its chemical name is sodium hydrogen carbonate. This baking powder relieves pain and irritation of bee and ant stings, which are acidic. So we are saying that we saw that in the last lesson, the last lesson, that the bee and ant stings are acidic. And when you are stung by an ant, you feel some kind of irritation and pain. So we are saying that this baking powder, which is alkaline, it can be rubbed on the skin or around the affected or the stung part of the skin, and it's gonna relieve the pain and therefore prevent the inflammation and further itching or pain. So we are saying that it does this as a result of the neutralization reaction that happens between the baking powder, which is now alkaline in nature, with now the bee sting rises the methanoic acid, which is injected into the body by the bee or the ant when it has stung you. Alright, we can have the next one, that they are antacids and therefore used to relieve heartburns and indigestions. Alright, we say that bases are analytically used to prepare important compounds like salts, which have various applications and use. We know very well that when these bases react with other substances, we do form compounds. And in this case, we are majorly talking of salts, and of which these salts are very, very important, are applicable in some aspects, and therefore serve the purpose there. We can also say that alkalis such as calcium carbonate, sodium hydroxide, and so on are used for qualitative and quantitative analysis purpose. So these ones, they are used to standardize solutions, or they can be used as reagents to test for the presence of other chemical species, which might be in a given sample of a reagent. We can also say that potassium hydroxide and sodium hydroxide are used in the manufacture of soap and detergent or shampoo. So these two are commonly used. We can either use potassium hydroxide or sodium hydroxide in the manufacture of soap. Actually, it is major detergents, detergent and soap, that we do use these alkaline substances or these bases. We can also have the sodium hydrogen carbonate, which is now baking powder, is used in the manufacture of dentifrices. These oral products, for example, the toothpaste, tooth cleansers, and the mouthwash, which are capable to neutralize the acids produced by bacteria in the mouth. We know very well that in the mouth we always have bacteria, which now go on producing the acidic byproducts. And when these acidic byproducts accumulate in the mouth, they cause the dissolving or the dissolution of the teeth, causing the teeth to dissolve in this acid produced by this bacteria. And therefore, to prevent that, we need to use the sodium hydrogen carbonate, which is now baking powder, that would neutralize now these acidic bioproducts produced by the bacteria found in the mouth. We can also talk of this, that baking soda is used in the cooking and bakery industry to make bread. You know very well that baking powder, which is now sodium hydrogen carbonate, is used to do the baking. Can be pancakes, can be other categories of bread we have on market. Alright, we can say that calcium hydroxide and potassium hydroxide are used in pulp and paper manufacturing industries. So in industries that produce papers or books, we do use calcium hydroxide and potassium hydroxide. So this one is very, very important and economical. And thanks for watching. We meet again in the next story. Goodbye.